Right, today we're just going to be looking at what's been going on this week in BHASVIC A1 doubles. Alright, just the topics, just you read. I'm not going to talk on about what's here. Pause if you want to read it. The assignment, it was a pretty easy one considering the last one, which was just filled with probability. Here are the main topics, and here is just some information about the questions and what I think is going to come up in the assignment test. This is just don't just take this with a grain of salt. The predictions, they're not going to be right. I'm just doing it just so if I get it right, then it's cool. If I don't get it right, then you shouldn't trust it. But anyway, let's do the main part, which is just going to be going through the assignment. If you're doing single maths, then it doesn't hurt to look through the assignment on the topics you've already done. Yeah, but let's just get into it. So we're going to just get the assignment up here. So firstly, we have some sketching. This is some easy stuff. I mean, part A is should be you just can kind of tell the roots from the equation itself. You know the x coordinate of the turning point. You can complete the square in your head, or you can just do whatever. You know it's upside down because the a term is minus, and you can do the same thing for all three parts. And this one I just completed the square because it's a bit more difficult to do in your head, but you can do whatever as long as the graph's fine. Next question, we've just got some differentiation. So for all three questions, just turn it into whatever form you want to turn it into. It's easiest to differentiate it and then differentiate. Just do that for all three of them. And you get these answers. For question 3, we have a similar thing, just for integration. Again, just turn it into whatever form you want it to, but I just integrated because it's already in a pretty nice form, so you can just integrate it by itself. Then this is one of the more difficult questions because we don't really learn how to differentiate. Well, it's not taught as much to learn how to differentiate negative powers from first principles. It's just a bit long. So obviously you just substitute x plus h, put it to the -2, I made them into fractions. You have to remember to write the limit on every line, obviously. And I'm just combining the fractions together, then expanding it. I think then I refactorized it actually because you don't need to expand the denominator of the fraction on the numerator. But then you just expand the numerator, cancel out the x squareds, and then factorize x and h out, cancel them, and then you just get this here. And you can just cancel the x's, and then you get that. And you can actually substitute the 0 from the limit in quite early because it doesn't really do much because it's not gonna divide by 0. Because as long as you can't divide by 0, then you can substitute the 0 in for h whenever you want. And you get obviously that answer. Next, we have some more first principles and also some optimization. So firstly, just do this first principle stuff again. It's just like simple stuff. I mean, it doesn't look very simple, but obviously it's just long, just expanding and cancelling, and then eventually you can divide by h and then cancel all the terms out. And then for the optimization, we should have done lots of these questions before. So it tells you the dimensions. So you can say that when you multiply all the dimensions together, you get 72, which is the volume. And if you add, and you can rearrange this, and then for the surface area, you just do 2 times each possible side length, and then combine them, substitute this in, substitute the h value into this, and you get your equation. It usually does give you the equation in these questions. It just tells you, like, show that you can get this equation, which is useful because then you could, even if you can't get the equation, you can still do the next parts. So obviously you differentiate here to get the minimum, set it to 0, solve. Pretty trivial. And then prove that it's a minimum. This is double derivative, obviously, and then you just, I don't know, right, what have I done here? You're supposed to substitute the value back in, but I've just not done it here. You're supposed to substitute it back in, it will be greater than 0, and then because it's greater than 0, it will give you a minimum. Right, next question, we have some integration stuff. So this is fairly new, because this is new stuff to A-level that we haven't done before, unless you did like OCR, FSMQ. So it's just, firstly, you have to find the the a and b, which you just set the quadratic equal to 10 because you know that y equals 10. You can just set them equal to each other. find these solutions. Then for the shaded region, you can imagine this as like a rectangle from AB and then downwards like this, and then you can subtract the area underneath the curve that's bounded by the rectangle, and then you get that area right there. So what I've done is I've done 6, which is the distance between A and B, times 10, which is just the distance between B and the x-axis, because this is y equals 10. So 60 minus the integral from the two roots, or the points of intersection, and then you can just compute this integral and you get 36. Next we have some circle stuff. This is stuff we should have done before. It's just a lot of rearranging. So you just rearrange, cancel the x. I don't know why there's a plus 3x here, because it's just going to cancel out. And then you complete the square on the y's. There's nothing for the x, it's just x squared, and you get the centre as 0, -4, and the radius is 3. Then you find the points of intersection between the circle and the y-axis, which is when x equals 0, when you just substitute x equals 0 and then solve, and it's already in completing the square form for you, so you can just do this, and instead of having to like expand and then do whatever, you could just solve it from this completing the square form. And obviously the x coordinate is 0, so you can just put that there. Show that the circle does not intersect the x-axis, where you can just, again, what have I been doing? You have to show that, you have to substitute 0 into y, and then you'll see that it's quadratic with no real solutions. So you can either use the discriminant, or you can just say that it's above the x-axis. I don't know why I haven't done that question. The next question, we have some trig stuff. This is just kind of standard stuff. We've done this before. It is kind of annoying, so you have to obviously do the range of values. So you have to minus 90 from the normal range. So for question 1 you get, or for A you get -90 to 270, and then you can substitute whatever you want as x minus 90, or you can just say that x minus 90 equals 45, x minus 90 equals 135 when you're doing inverse sine, and then you can just add 90 onto the answers. But if you want, it does make it easier if you try and use a substitution, just to make it look nicer, instead of having like a weird equation. The next thing, I said that instead of having to do the entire thing again, it equals the same thing, and you know that because cos is just translated, cos is just sine translated 90 degrees to the left, so you can just say that cos of x minus 180 is just sine x plus 90 minus 180. So you can just say that this question is literally the exact same as the previous question, so the roots are the exact same. And then for question 3, it's just another, you multiply the range by 3, and then do all this stuff. And obviously because it's tan 3x, it's going to be squished in, so there's going to be a bunch of different solutions, like this. And that is the question. All right, question 9, this is just some discriminant stuff. So you don't have to do this if you don't need it, but you can write like what A, B, and C equals, so it's much easier to do the discriminant. And then it's just a quadratic at this point, and we find that p equals -5 because we end up with a binomial. Next, part B, we have kind of the same thing. So you just write A, B, and C, do the discriminant, A equals 0, and you get the values of k, and that's it really. Next question, this is, if you did AQA further maths, this is similar to what came up on paper 1 on one of the questions, where you know that the area must be at most 75, which means that xy is less than or equal to 75, and you also know that the width, or just x, is it's greater than 3 but less than 9, so you can write this inequality down here. And you also know that this fence, not including the wall, must equal 25, so I've just called the bottom length y, and so you know that 2x plus y equals 25, because that's going to be the fences that they can use. And then at this point you can do what you usually do, where you just set, so you say that x equals 75 over y, and then you substitute that in to this, and then you find what's equal to, and because you have a quadratic inequality, you can just use this to solve that. You know it's less than 0, which means you have the thing from earlier where you have 3 to 9, and then you have 5 and 15/2, which you can express. You can combine those inequalities together because they're separate ranges. They're not like in the same area, so it's either from 3 to 5 or from 7.5 to 9. So you have to write that as separate inequalities, and there's no like set notation here. It doesn't say a set, it just says the range. Right, next question. This question is pretty interesting. It's kind of just worded pretty badly because it doesn't give you a diagram. It's just a lot of calculus in the same question. So firstly, you need to find the normal, so you can find where it meets the x-axis. So you find the derivative, find the normal, do all the coordinate geometry stuff. Then you set it y to 0 because you want to find where it meets the x-axis. You find that what x equals 11, so the coordinates 11, 0. And then I drew a diagram like this, and I realized that the area is the area of the triangle, take away that little area that I shaded there. And what I did is I drew out this area, and I said that the area of the triangle is 121/4. The area of the green trapezium is 21/4. So you can just say that what I'm doing is I'm doing 21 minus this integral will give us the area that's shaded, and then you do 121/4, take away that, so that you can find the area that it's asking for, because it says it's bounded by the x-axis, which means it's above x equals 0, no, y equals 0, sorry, and also bounded by the y-axis, which just means it's not going to go further, and then it's also bounded by the line PQ, which means that it's just not going to go above that. And also the curve, which means it's not going to go above the curve, that's why we're taking away the shaded area. So it's literally just the triangle that I've drawn here, take away the area, which I've done, and you end up with 88/3. I think in an exam, they would be a bit more like lenient with the wording here, because it doesn't tell you what area you're trying to find. You kind of just have to figure it out yourself. And there could be multiple different areas that it could, like I thought initially that it would be the area just in the trapezium, but then you kind of have to reread the wording a lot of times to be able to figure it out. Next question, we have find the value of k for which that is a tangent. This is just some more discriminant stuff basically. So we're going to go on, we're going to substitute y equals 3x plus 1 into this, do the discriminant, and then solve. It's just some more discriminant. I mean, there's a lot of discriminant stuff in this actually. I didn't really realize, but they have put the discriminant here a lot. Next question. This question it looks incredibly intimidating with all this like weird values and these a's and the square roots and all this trick stuff, but realistically it's so like that everything simplifies instantly. So like for a, this is obviously just because it's half theta doesn't mean you can't use the identity on it. So this is just sine half theta because it's just because of the identity. The second question is just, again, just because it's sine squared 3 theta plus cos squared 3 theta doesn't mean it doesn't still equal 1. So it's just 5, because you can factorize 5 out of this, and then sine squared 3 theta plus cos squared 3 theta equals 1. So they will just cancel. Same with this, it's just the identity, but multiplied by -1, so you get negative cos squared, because cos squared equals 1 minus sine squared, but if you multiply the entire thing by -1, you get negative cos squared equals sine squared minus 1 instead. For this question, you just use, you could either convert the tan into sine over cos and then see that they cancel out, but I just used the triangle here, so we know that tan equals sine over cos from the identity, so if we were trying to find sine over tan, that's going to just give us cos, which it does. E looks scary, but this literally just simplifies to sine because it's sine squared rooted, so it's just sine, and then that just simplifies to tan because it's sine over cos. Same with this question, this is literally just sine over cos 3a, which just gives us tan 3a. This next question, again, looks scary. It does give you a few things that you have to do, but they all cancel out in the end because you have this first bracket gives you this quadratic, the second bracket gives you this quadratic, and then you obviously have the 2 cos squared, but because there's 2 sine squared plus 2 cos squared, that just cancels to make 2. The positive and the negative 2 sine x cancels, and then you just have 1 plus 1 plus 2, plus 2, which gives you 4, and that's the answer. Then h, this is just factorising sine squared out of this, and you just get sine squared times 1, and then it's just sine squared. Then, and this question is just stupid, because if you should be able to see this. It's literally just sine squared plus cos squared squared, and which is just 1, because it's just 1 squared. So all just very it's just trying to scare you with all this trick stuff. I don't know why, but it's really just simplifying. Next we have some modulus graph. I've sketched it like this, and you find the root by just setting, you can set x to 0 and set y to 0 to find the different coordinate intercepts. And then we're setting it equal to a third x, and if we know that a third x is going to be like, I don't know why I haven't drawn it on, but it's going to, because the gradient of this is just 1, the gradient of this modulus graph, and the gradient of this is a third, we know that if we draw a third x, we know that it's going to intersect twice. So we're going to need to do it with the positive and the negative part of the modulus. So I've done minus x plus 2a. No, I've just done the positive version, x minus 2a equals a third x, and solved that, x equals 3a. Then I've done the negative version, so negative x plus 2a equals a third x, and you solve this, and then you get these two solutions, and those are just the answers, because it doesn't say the coordinates, it just says x in terms of a. Next question. This is the last question. This is an incredibly long question that, I don't know. There's just a lot of stuff you have to do. So firstly, you have to differentiate, so you just expand, find in a good form, and then differentiate so you can, in the form that you want it to be. So coordinates of point A is just going to be the stationary point, so we set the derivative to 0, solve, it's just some rearranging, and then we substitute 4 back into the curve, get y equals 112, and that's the coordinates. Next part, we have to find next coordinate of point B, which is just the other root. We know that the other root we know one of the roots is 0, 0, so if we just set this to 0, the entire thing, we know that if we divide by the thing in the brackets, we're just going to get x equals 0, which is the root we don't want. So we divide by 7x squared, we just get 5 minus 2 root x equals 0, and then we solve that to get x equals 25 over 4, which is obviously just, I haven't wrote the coordinate, but it's just 25 over 4, 0. And now we have to integrate. What I've done here is that I've said that the rectangle, so from A, where A and B are two of the vertices, is 252, because we know that from A to B is 112 from this coordinate up here, and we know that from B to the x coordinate of B to the x coordinate of A is just 25 over 4 minus 4. So we know the area for the rectangle is 252 by multiplying them, and then we just do that, take away the area under the curve to just get the area not under the curve. So we just integrate from A to B, get whatever we get, and then this, you take it away from 252 to get the area that we're looking for. Alright, now we're going to section B. There's a lot of functions in this section, and we're just going to do some more graph sketching, just warming up, I guess. And we're just, so firstly, it's a reciprocal graph, draw the asymptotes, you have to translate it, 2 to the left, 1 up, and you have to do the ranges as well. For this one, it's just it's all real numbers except 1, because 1 is an asymptote. Then 1 minus sine 2x is just sine 2x, was negative sine 2x moved up 1, which means that, because usually sine won't start at the top, but because it's been flipped and then moved up, it will start at the bottom. And yeah, sorry, I'm just doubting myself. And we can see the range, because usually sine is from 0 to 1, from negative 1 to 1. So if you move that up by 1, that's going to give us 0 to 2. And yeah. Next question, h of x equals root of 1 plus x. You should know the graph of just root x is this, so, but moved 1 to the right. So if it's 1 root 1 plus x, it's just moved 1 to the left. They tried to confuse by putting the 1 first, but that's not changing anything. And the range is just h of x is greater than 0. This translation doesn't affect the range. And that is the first question. So next question, we have big question about modulus and some functions. Firstly, it's asking us to sketch these graphs. So here we're just translating it to the left, and here we are reflecting it in, we're reflecting the right part in the left part of the, so we're reflecting the positive x part into the negative x part and replacing the negative x part with the reflection. Then for C, we're finding value of a and b for just these coordinates here. It's telling you the equation, so we just know that the stationary point is just going to be where the two lines meet, which is just going to be -2, because if this kind of looks like the completing the square form, right? You have x minus 1 minus 2, so it's just going to be 1 negative 2, because that's where the lines intersect, and you already know that the y-intercept will be -1 as well. Next question, we have just setting it equal to 5x and solving it, and we know that I've redrawn it here. We know I've taken the 2 away from this side because otherwise it makes it a bit more confusing. And we draw both lines, and we see that 5x plus 2 only intersects it at the negative part. So what we do, we just use the negative part. So we do negative x plus 1 on the modulus, and then rearrange to make negative 1/6. Alright, next question. This is very long-winded, wordy question. So firstly, we're just going to find the inverses and this composite function, which is just like setting it equal to y, doing whatever. I think we know that obviously the inverse of 1 over x is just going to be 1 over x, and this you don't even have to really do any working out for the inverse of f because it's quite a simple function. And then the composite, you just put 3x plus 2 into 1 over x, which again is pretty easy. Just the domain, just make sure that you can't divide by 0, like this. And then for the next question, we have to show that both of these things equal this. So it's basically just telling us to find that from both functions. So firstly, I think I did gf negative 1 first. Yeah. And I rearranged to find that. I found gf and then put it into its inverse form, which is this, and then you can factorize a third and then separate the fractions out. f1 g negative 1, f negative 1 g negative 1 took me a little bit longer, but that's just because I kind of messed up at first. So obviously we have to put the 1 over x into this. We just have to multiply the functions together basically, and then that will eventually, if we do some factorizing, then we can eventually, so I multiplied both sides by x to get rid of the 1 over x on the numerator, and then that will eventually turn into what we had over here, which we can just do the same thing. Next question, we have the inverses, so we're doing the inverse function, and we know that because all the domains are greater than where the stationary points are, we know that when we square root, it's just going to be the positive, which allows us to take the inverse. So like for this one, you just set to y and then rearrange for x, and that's the domain. And then you state the domain of the new inverse. Same with all the other ones. It's kind of just the same thing. You set it equal to y, rearrange, type it as the inverse, and then do the domain. Next question, we have some more modulus stuff. So we've had like I think 5 consecutive function questions now. This is some more graph sketching, part A, a over x squared. It's just both are in the positive region because it's x squared. And also it's not necessary for those modular signs, but the first graph is because it's already fully above y equals 0. So we don't need, like, doing modulus won't do anything because it's already above that line. And then the graph is symmetrical in, no, I didn't mean y equals 0. And the graph is also symmetrical in x equals 0, which means that doing k of mod x isn't going to do anything because usually you have to reflect it, but because it's symmetrical, reflecting it won't do anything. Next, we have another function, which is just the same thing, except a is not greater than 0, which means that you have to sketch this. You know that because a is less than 0, it's going to be just the same thing but negative, and you have to look at these functions. So what I've done for these functions is I've just applied them to the function and kind of just thought, will this work? So obviously for this function, modulus of the entire thing, that's just going to make the a positive, which means that they are going to equal each other. For this one, though, putting the modulus on the x won't do anything because it's the negative a, which is what's making the m of x negative, which means that these won't be equal because this one would be negative, this one would be positive. And then this one will be right because, again, it's the a that's affecting what makes it negative. This one will be right because this one will be right because a is what's making it negative, so it's going to be negative either way. It's not going to be, the modulus on the x doesn't affect it whatsoever. Next question. Oh yeah, so this question, obviously you just do some binomial expansion to start. What they wanted you to do with this question is they wanted you to sub, well, pretty obviously, you just had to sub 3y plus y squared into the x cubed term. So you would just do 40 times 3y plus y squared cubed. But what I did instead is I did this way, which I would highly recommend watching Arthur Drutu's video on multinomial expansion. But basically, if I could simplify it here, the coefficient of the y cubed term could either be from the 1y and 1y squared, or 0y squareds and 3 just y's. So we have to account for both of those scenarios. For the first scenario, we know that n is the sum of all the powers. So we want, for the second scenario, for this scenario, we know that n is 5 because it's the sum, it's the power, and we want 1, 2, we want 1, 2, we want 1, oh my god, what am I doing? We want 1, we want 1y squared, we want 1y, and we want 3 2's, because that's the other thing. We don't want any other y squareds or y's, we just want 2's. So which means that it's going to be 5 factorial over 3 factorial, 1 factorial, 1 factorial. But 1 factorial is just 1, so we can cancel it. And for the other term, we want 0 y squareds, we want 3 3y's, and we want 2 2's, which means it's just 5 factorial over 2 factorial, 3 factorial. And those are going to be the terms in this series. Me explaining it probably makes it sound incredibly complicated, but I'm not the best explaining new concepts, so I would suggest watching the video before listening to me do it. But anyway, you get 1,560 however you do it, I think. And for the next question, we have just some radian stuff, so now a bit simpler and just a bit more chill from all this function stuff. Firstly, it's just a sector. We're finding the value of theta. We know that the arc is 32.1, and we know that r theta equals L. So we just know that 15 theta equals 32.1. We can find theta pretty easily. Then finding the area of the sector, just half r squared theta, just normal formula stuff. Next question. This question I think we've seen many times before, so I'm just going to skip through it kind of, because we saw it, basically, we've seen a similar question earlier in this, two of similar questions earlier in the assignment, and we've also seen this in our test, and we've also seen this before in lesson. So I can kind of just skip through it. We know that this is going to be the surface area because theta is 1, so it just cancels from everywhere. And we know that the volume is 300, substitute the stuff in, get this equation, find the derivative, set it to 0, find the minimum value, then do the derivative again, substitute the value in, say it's greater than 0 for a minimum, and then substitute that back into the main equation. If you haven't seen this question before, then I'd be surprised, so I'm not going to... And if you need more practice, if I explain that too fast and you need more practice with optimization, then just go look at the earlier questions in the assignment. Next question, we have some probability, which is giving me flashbacks from the last assignment. Tree diagrams first. We just got some GCSE stuff, easy stuff. and we're just finding the probability. So both journeys are on time, it's just going to be 0.7 times 0.7, and then one journey is on time, there's two different combinations of 0.3 and 0.7, so we can just multiply that by 2 and get 0.42. Next, we've got some mechanics, we've got some projectile stuff. They like using trig ratios for some reason, which is annoying. But we know that from these trig ratios, we know that the hypotenuse will be 5 because it's a Pythagorean triple, and we can find cos theta or cos alpha and sine alpha, which is useful because we need to find the different components of the velocity. Then I think most of us will have seen the way to generalize the formula, so you know that this is going to come from s equals ut plus half at squared, but it's going to be in the horizontal bit because ua is 0, which is going to cancel out the half at squared, and from that we just get s equals ut, or 8, which is this distance, equals 4/5, which is cos theta times u times t, and we can rearrange that to get 10 equals ut. For b, we can sort of rearrange this, and I'm sure we've seen this before as well, and we do the vertical now. We do the vertical, same equation, but vertical, and then we substitute u equals 10 over t into this equation, get a quadratic, or not even a quadratic with t, just get an equation with t, and then find it from here. Next question. This is, they love doing this for some reason. You need, as the ball hits the ground, its direction of motion makes this angle, which means that you need to find the horizontal and the vertical motion, and then you do Pythagoras. Oh no, sorry, you do tan, inverse tan, to find the angle. But here it's just asking for tan of the angle. So what we do is we just find the vertical with v equals u plus at. We do the exact same thing with the horizontal, and we have these two are the different velocities. And we can just do tan, we can do opposite over adjacent, which is going to give us tan of the angle. It's not asking us to find the angle, it's just asking for tan of the angle. So we just leave that in as 1.75. Alright, this next question was one of the more difficult questions as well, as same with the last one. We have to firstly just get speed time graph, which isn't going to be the hardest thing. Obviously I've made annotations to this because it comes up in the next questions. We know that the entire area is 2,145, and we know that it maintains a speed at 22, and the point that it stops we'll just call x, and we know the distance in between 30 and x is just t. Next, we're finding the value of t, so we know we can just form an equation for the entire thing and set it equal to 2,145, because we know the area, that's what the area equals, and we can just rearrange to find x equals 105, and we take that out, 30, take away that, to get the distance in between x and 30, or 75. Next, we have this motorcycle. This was the hard part of the question. So we have this motorcycle that starts at 10 seconds, and it's going to intersect this some part of this straight line here in the speed time graph. It's actually going to go above the velocity of the car at some point, which we'll see later. And first we were finding the time it takes for the motorcycle to do this. We know that it passes the car at point A, which is 990 meters away, which means that at the point that it intersects, it's going to be the ratio of the area with the rectangle. So what I mean there is that if we take away the area of this triangle, we know that it's going to be 660 meters into the rectangle that goes from 30 to 105 up to 22. It's going to be 660 meters into that. And that rectangle is 1,650, and we're trying to find 660 meters into the rectangle. So we find the ratio, which is 0.4, multiply that by the distance in the x, and we get that it's 30 seconds into being it's 30 seconds into when the car is at constant velocity, which means that it's just going to be, and if we add 30 onto that, we know that the answer is going to be 60, because it intersects this point when we know that it's when the car is moving at 22 meters per second. For the next part, you need to take away 10 at the end because it leaves 10 seconds after the car leaves. Forgot about that. Next question, we're finding the value of a, which is just the acceleration. I decided to use suvat here because it was just to be easier. You know the distance because we know what time it is. We know that the initial is 0 because it tells you that it's from rest, and then time is 50 because we just worked that out, and we can just use s equals 80 squared because you were 0 to find that. All right, bit more of an easier question, I guess. It's still not easy, but a bit easier. Firstly, we're finding the area of the sector, which is just half r squared theta. That's pretty easy stuff. Then there's probably a different way you can do this, but I just said that the arc AB kind of just looks like half of the circumference. If you wrap arc AB around C, the circle, it's kind of half of the circumference. So I said that the arc is 2 pi, so if you multiply that by 2, that'll be 4 pi, which I've just said is the circumference of the circle. And when you have something that looks like this, because it's a concentric circle, it's touching all the sides of the sector, we can kind of assume that if we enclose this arc length, it is going to be half of the circumference. So I've just said that the total thing is 4 pi, which means that the diameter is 4, which means the radius is 2. 2 meters. No, centimeters, sorry. Next, we're finding the area of the shaded region, which is just the area of the sector. Take away the area of the circle. I don't know why I've put it in the wrong order here because I did do it right. So the area of the sector is 6 pi, the area of the circle is 4 pi, and we're going to just take them away from each other and get 2 pi. All right, question 13. We've got some probability, again, reminding me of the last assignment. This is actually an easier question. It felt like to all the probability ones in the other assignments, or maybe it's just me understanding it more after having to do 15 straight probability questions. So firstly, we're just finding P of B, which is going to be P of A intersection B over P of A. Then we are going to find P A union B, so which is just 1 minus, because P, you know that P A complement intersection B complement is literally just the outside, so and P A union B is just the inside. So if we do 1 minus the outside, we get the inside, which is going to be A union B. Next, we're finding the probability that it's not in A, but also that it's in B. So if you imagine that as a Venn diagram, it's going to only be the bit that it's in B, but not in both of them, which means that it's going to be what's not in any of them. It's going to be what we just found, A union B, take away the entirety of A, because we know it's not in the alone section of A, and we also know that it's not in both of them. So if we just take away the entire inside of the Venn diagram from A, we're going to get what's in B, but not what's in the middle. So we're just going to get 0.18 for this. So I definitely should have drawn this as Venn diagrams. You kind of just have to imagine it. P of B dash, I don't know why. So for this one, you need to find the probability of A given that it's not in B. So first you find the probability of that it's not in B, which you can find much more easily from just doing, because we found P of B being 0.3, so we can just do 1 minus that. I don't know why I did this convoluted way of finding it, but we can just find it doing 1 minus 0.3. Then we know that it's not, given that it's not in B, which just means that it's either not in, it's either in this section of A that I've drawn, I've like done in bold, or the outside, given that, so this, it's the, sorry, oh my god, I'm stuttering. So not in B is just anywhere that isn't B. Given that it's not in B, what's the probability that it's in A? So we're just thinking it's the probability that it's just in A, not in the middle, over the entire probability of it not being in B, because that's the total. So the probability of A minus the probability of A intersection B, which is just going to be the area that I've got in bold here, divide that by probability that it's not in B, you get 0.4, which is going to be the answer, because we know the total is always going to be on the thing on the right side here, because that's what we're given. It's given that it's not in B. which means that the total probability is going to be 0.7. The total probability of this situation, and then the probability of what we need to actually find is probability of the entirety of A, take away the middle, which is just going to give us this area here. All right. Yeah, I'm not the best at explaining probability, as you can tell, because I'm not the best at it. But we're just going to fly with that, I guess. Next question, we just have some triangle sector stuff. So find the angle of PRQ. This actually took me a while to see because we haven't done sine rule since GCSE. So this is literally just sine rule, and you find it at 0.48 radians. Next, we're finding the area of the shaded region. So firstly, I found the area of the entire triangle. So I just said that this angle PQR is pi minus 0.48 minus 0.7. So just pi minus the other angles, and just did half AB sine C to find the total area of the triangle. And then I took that away from the area of the sector. And that just gives you the overall area. There's probably a few other ways you can do it, but that's just one of them. But next question. So this is just obviously pretty. This is obviously common knowledge. I mean, if you don't know everything about the large data set, then what are we doing here? So obviously 10 decameters equals, we know that decameters is just meters times 10 to the negative 1. You should know that from, I think it's from GCSE chemistry, where you do quantitative chemistry, you use decimeters cubed. Because it's decimeters cubed, to go from meters cubed to decimeters cubed, you multiply by 1,000, which is just, no, you divide by 1,000. But to go from just meters to decimeters, you divide by 10, because it's just the cube root of 1,000. Or you can just remember that. So you can do these conversions quite easily. So one's going to be true, because it's just 100 times 10 to the negative 1. Same with 2, and same with 3, because you just convert a kilometer into 1,000 meters. Obviously for 4, the abbreviation for decameter, even though in chemistry it's dm, when they're actually doing it for the large data set, it's dam, which is weird, but I guess that's how it works. Which of the following are true? So obviously I is true, because otherwise why would we be learning about decameters? Visibility is defined as the greatest distance. Well, that's obviously true. 3 is also true, because it's just another definition of visibility. We should just know these definitions. Obviously 4 is false, because it obviously, as we should know, it is a visometer, not a visimeter. This is ridiculous. Anyway, and visibility, this is actually quite obvious. All jokes aside, it is measured horizontally, not vertically, because if you think about it, you can't measure how long you can see into the horizon if you just look straight up, because you're just looking into the sky at that point. Next, this is another ridiculous question. So we have Heathrow, Herne, and Leeming. And we have to try and identify which one's which. We know that that also, firstly, I've done the second part first. There isn't enough data for a reliable assumption, because there's only 7 samples. But we know that we're supposed to know that Herne is the farthest south, Heathrow is in the middle because it's near London, and then Leeming is the farthest north location apart from Lucas. So we know that we need to know that visibility is lower in the south. So that means that Herne is A, because it's the lowest, it's the lowest average. Heathrow is the middle, because it's in the middle, and then the highest visibility is in Leeming, which is going to be in the north. Right, thanks for watching, guys. We'll see you after half term, actually, for the next assignment. Next week, I'll be doing proof, factor theorem, and partial fractions. I don't really know why we're doing partial fractions at this point, but anyway, but it's mainly proof though. So good luck with that, and I'll see you in the next 2 weeks.